Hello, good evening everyone. Welcome to BYJU'S Exam Prep. So this is the GATE and ESE 2024 fundamental series. So yes, the audio and the video is absolutely fine, right? So now we know that in this particular series we are actually understanding the basics, very fundamental of the subject EMFT. Like in the first class, we understood about the vector algebra. In the second lecture, we discussed about the coordinate system, where we discussed the three different coordinate systems, right? Cartesian, cylindrical, spherical. Now, this is the third lecture of this EMFT basics. Because this is the basic, so I am only telling the basic thing which is required for the GATE examination. I am not going into the depth of the concepts, and I am also not going into the superficial level. I am only covering the part which is required to solve the problems and to understand few particular questions. Yes, will you teach for all subjects double E gate? Double E gate, I am not going to cover all the subjects. I will be covering in the YouTube EMFT and maybe later on say, signals and systems. Okay, Satya. So, any more doubt about the subject that which you want to learn? In the YouTube, I am talking about in the BYJU'S platform. If suppose you buy the course, if you pay the course for the complete year, that is for the GATE 24. If you are targeting either you are targeting ESC, then that would be different. There, that in the platform in the app, I teach the different subjects like the communication. Also, I will teach for the electrical students that is for ESE. So there are multiple subjects that I am dealing in the app, but in the YouTube I am only discussing the EMFT and the communication. And maybe later on I will also cover the signals and systems, right? So let's go into the start. Just brief introduction about myself, Satya. So this is Saket Verma, and I have more than 12-year teaching experience. So it is about to come around 13 years. Also, I will be finishing in the next month. So qualification is my MTech. I have done in the IT Guwahati in the signal processing branch. I have already cracked the different PSU exam as well, and more than lakhs of students I have already mentored in this last 12 to 13 years. And then my area of expertise, as I told you, that there are multiple subjects that I teach, like ICT, that is the Information Communication and Technology. For the ESC, also I am teaching signals and system. I am teaching presently the batch signals and system. I just finished, and again the next week I am starting the new batch on the signals and system. So these are the various subjects that I am covering. Okay, and there is very important for the all the CS and the EC student, that is the NILIT workshop, how you can become the NILIT scientist and IC scientist in just 50 days. The roadmap, what you have to prepare, what are the different things that you should look for, all the things will be covered by the Satya sir, that he has already more than 15-year experience, and he will be telling you about all the roadmap to reach to this goal in the 27th of April, 7:30 p.m. So let's go into the today's topic, which is the differential elements. So in the differential element, as we know that in the Cartesian coordinate system, the space we look in the form of a cuboid, right? That is the, you can say, in the shape of your room. Whatever will be the shape, you can see the room of your house as a Cartesian coordinate system. So actually the whole space we want to cover, and in the whole space our room is like a small differential object. So I am taking one small object which is the differential volume in the Cartesian coordinate system. So this is my x axis, y axis, and the z axis, and my unit vectors in the direction of x is ah, in the direction of y it is ay, and in the direction of z it is az. Right now, suppose we have this differential object that I am representing as A, B, C, D, and like this is P, Q, R, and S. Okay, so these are the different points on this block. Now, Suppose you wish to move from one point A to another point C. Okay. So I'm saying that suppose we wish to move from point A to C. Okay, suppose you want to move from A to C, then what will be the path? So you may be following A to B. Okay, you may be following A to B and then B to C. There may be another path also, but I am considering A to B and B to C. So because you are you want to go from A to C, I am saying we are following the path AB and then we are moving BC. Okay, A to B and B to C. So wait a second, guys. Okay, now we are moving from A to C. To move from A to C, we are moving from A to B and B to C. Correct? Now, let us suppose the AC I am representing as the DL, differential length. So to move from A to C, I am moving in the AB. So AB is parallel to the y-axis. So if it is parallel to the y-axis, you will take the differential length along the y-axis, which is dy and ay. And because you are moving from B to C, you are moving parallel to the z-axis. So it will be dz and az. So this is our differential length. Suppose this is just to move from A to C. Suppose you want to move from A to R. Then to move from A to R, I am following A to B, B to C and C to R. So this is A to B, B to C and then C to R. So A to B is same dy into ay and dz into az and now C to R. Why I am writing the unit vector positive? So by default we always write the unit vector positive because as you can see that when I move from A to B I am moving in the positive y-axis and when I am moving from B to C I am moving in the positive z-axis, that is upward direction. Now when I move from C to R, actually I am going in the opposite direction. You can see that this x-axis is having the positive x direction in this direction, means outside the screen. But when I am moving from C to R, I am moving inside. So when I move from C to R, I am moving in the inside the page in onto the paper. So that is why I will write the direction as minus x. So in this way, you will write the differential length. So the differential length in general is always given by the differential length in general, irrespective of the direction, we always write dx, dy, ay, and dz, az. This is the differential length in the Cartesian coordinate system, irrespective of direction. Now, the question will come that how we are going to manage the direction. So, the direction is managed by the direction of length or unit vector. The direction of unit vector is compensated by limit of integration that we will discuss when we will solve the questions. Okay. Now, if you want to write the differential length, I have already written. Okay. Now let's write the differential surface. The magnitude of the differential length. So how do you calculate the magnitude? Suppose this is the differential length dx ax, dy ay, and dz az. Then how will you write the magnitude? So the magnitude of differential length is nothing but a root over dx square, dy whole square and dz whole square. So this is our differential length. Now let's come into the differential surface. So suppose I take the front surface of the cuboid that we have taken, that is the differential volume. That is the first. This is the front surface. Okay. This is the front surface which I am representing as ABCD because I have denoted it as a ABCD in this diagram. ABCD. So this is the front surface. This is the side surface which is BQRC. Okay, this is the side surface which I have taken as BQRC. So this is BQRC. Now this is the top surface which is DC and PQ. No? PQ. Yeah, PQ. So it is PQ. So in the cuboid, if you will take this particular surface, okay, that in the differential volume, if you take this particular surface, then this AB is in the direction of Y. This AB is in the direction of Y, so you will write it as a dy. And this BC is in the direction of Z. So it is dz. Now, if you want to write the area, then how will you write the area? Because this is looking like a rectangle. So the rectangle is having the area dy into dz. Now, whenever you write the differential surface and the differential length, both are the vector. Means it will have the direction also. So the direction is always perpendicular to the surface. The direction is always perpendicular to the surface. So because you are writing dy and dz, so y and z. So what is the perpendicular to y and z? That is x. So this is ax for this particular first diagram. But this ax can be negative also. If you take the back surface of the differential volume which we have taken, the object that we have taken, if you take the back surface, then it will be in the negative direction. So it can be positive also, it can be negative also. So if you will write the differential surface, in general, it can be positive and it can be negative. So always take the surface, direction of surface, always take the direction of surface is normal to the surface. Whatever surface you select, always take perpendicular to the surface from inside to outside. Inside to outside. From inside to outside, you have to take the direction. Like in this case, suppose this is the point which is inside the differential volume. So this is ABCD which you want to take. Now inside to outside, when you will move in this direction. Or if you talk about this back surface, then you will move in this direction inside to outside, right? Suppose you are at this point P and you are taking this particular surface, the side surface, then perpendicular to the surface, moving from inside to outside. This is inside, you are at inside point and this is outside point, right? Now when you move from inside to outside and that to normal to the surface, that will be the direction for this side surface. Similarly, if you are considering this surface, then when you move from inside to outside, you will move in this direction. So depending on the surface, you can calculate the direction. So as I said, the right side will have the positive direction and the left hand side will have negative direction. And this top surface, when you move from inside to outside, you are going in the positive z direction. So this is a z. So what will be the differential surface then? The differential surface, when you write in the direction of x, this is dy dz into ax. When you write in the direction of y, it will be dx into dz. And when you write in the direction of z, it will be dx into dy or vice versa. You can say that differential surface is x into y. If you are taking x and y, then the direction is z. It can be plus or minus. Differential surface can be dy and dz. Because you are taking y and z, the normal will be x, so plus minus ax. And the differential surface will be dz into dx. If you are writing z and x, then the direction may be plus minus 1. Okay? So in this way, you can. Now, whenever you want to write the differential volume, Whenever you want to write the differential volume, just multiply all the differential element you know in that particular coordinate system. So in the Cartesian coordinate system, what are the differential element? Dx, dy, dz. So multiply all of them. Okay. So to write the differential surface, differential volume, both, if you want to write, you should remember the differential length. If you are able to memorize this differential length in all the coordinate system, it will become easy. Suppose you want to write in the x direction, then multiply the y and z. I am talking about differential surface. If you want to write the differential surface in the y direction, then multiply x and z. If you want to write the differential surface in the z direction, then multiply y and x. Correct? Similarly, if you want to write the differential surface, differential volume, if you want to write the differential volume, multiply all the three coefficients of unit vectors. Multiply all the three coefficients of unit vectors. Now coming to the cylindrical coordinate system. So in the cylindrical coordinate system, in the cylindrical coordinate system, in the cylindrical coordinate system, the differential length, again, if you want to see this A, B, C, D, so there are actually three elements. You can see that this is d rho, rho d phi, and dz. Then what is the differential length? The differential length is in the direction of rho, this is d rho, and what is the unit vector? A rho. And in the direction of phi, what is the magnitude? Magnitude is rho d phi. And what is the unit vector? A phi. And in the direction of z, what is the magnitude of differential element? Dz. And this is Az. So this is the differential length. Okay. This is the differential length. Got it? Okay, now as I said that suppose this is A, B, C, D, and whatever it may be, let's write according to the surface. Let's write this. Suppose if I talk about this surface, again you are in the inside and inside to outside you are moving. So when you are moving from inside to outside, you can see that by which axis you are moving away. When we know that the rho is the distance moving, rho is the distance away from the z-axis. So when you take this direction, means when you are moving inside to outside and you are taking this particular surface, so when you move from inside to outside, you are moving away from the z-axis. And whenever you move away from the z-axis, the radius will increase. Whenever you move from the z-axis, the radius will increase. That means that will become the direction of rho. Okay. And now when you talk about the top one, so when you move from inside to outside in the upward direction, that means you are taking the top surface of the cube, okay, of this object. That means you are moving in the positive z direction. And when you move in the x direction, that means in the anti-clockwise direction, so that will become automatically the direction of phi. So in this way we get a rho, a phi, and a z. So here we have written this is the direction arrow, this is the direction a phi, and this is the direction az. I told you how to write the differential length, how to write the differential length, how to write the differential length. Differential length is, let me write over here, this is the direction arrow, this is the direction a phi, and this is the direction az. What is the differential length? The differential length is your d rho arrow cap, then rho d phi a phi cap, and dz dz cap. Okay, now suppose I want to write the differential surface for the first diagram. For the first diagram, that is in the direction of rho. So I told you how to write. If you want to write in the direction of rho, then you have to multiply the coefficient of other two components. So the coefficient of phi and z. What is the coefficient of phi and z? That is rho, d phi, and dz. Okay. Now, if you want to write the differential surface for the second diagram, because you want to write in the direction of phi, because you want to write in the direction of phi, because this surface has the direction phi, it may be positive, it may be negative. So if you are writing in the direction of phi, then multiply the coefficient of other two. What is the coefficient of other two vectors? The other two vectors are a phi and az. So the coefficients are d phi and dz. And for the third diagram, the direction is z. So what are the coefficient of other two? The coefficient of other two is rho d phi. Okay, that is rho d phi. In this way, you can write the differential surface. The direction can be positive and negative both, because you want to write in the direction of z. You are taking the coefficient of other two unit vectors. Okay. Now, if you want to write the differential volume, how do you write? Differential volume is the nothing but product of all the coefficients in all the three directions. The coefficients are rho, d phi, and dz. This is the coefficients. So just multiply them, you will get the differential volume. Very simple. Now, coming to the last topic, which is spherical. So in the spherical, we are considering this object. In this object, we are having the x, y, and z coordinates. This is the phi, and this is the angle d theta, because this is angle theta. So in the theta direction, we have d theta. So this is our yeah, this one is r into d theta, because the radius is r. And how do you write arc? How do you write arc? Arc is nothing but the radius into angle. So the radius is r and the angle is theta. So this is r d theta. And in the direction of r, the differential length is dr. So from this point to this point, you are moving away from the origin. So when you move away from the origin, the radius will change. So if in the direction of radius, if you are taking very small distance, then it will become dr. And sorry. Yeah. So now, when you move in the direction of phi, it is r sine theta d phi. Actually, it is rho d phi. It is actually rho d phi, and rho is r sine theta d phi. Okay. So in this way, you will get. So what is the differential length? The differential length is dr ar cap plus r d theta a theta cap plus r sin theta d phi a phi. Okay. So this is our differential length. So once you write the differential length, how do you write the differential volume or differential surface? So let's find the differential length we have already written. Let's find the surface. So what are the surface? As you can see that this is x, this is y, and this will be your z. So because you are moving away from the origin, so this is in the direction of r, you are coming downside, that means you are moving away from the z axis. So when you move away from the z axis, that will become theta, because that will be the increasing angle. So that is theta and that is phi. So in the direction of r, theta and phi, how will you write the differential surface? So I told you that to write the differential surface, first of all, you have to choose the direction. So if you are selecting any surface, first of all, try to find the direction of the surface. So suppose I am finding the direction which is r. So if the direction is r, then what is the coefficient of other two? The coefficient of other two is r d theta, and the coefficient of the next phi is r sin theta d phi. So what will be my differential surface? This is r square sin theta d phi in the direction of r. Okay. Now, because I have chosen one surface, and on that surface I am seeing that the theta is changing. So if theta is constant, that means the unit vector will be in the direction of theta. So if you are taking the direction of theta, then what is the coefficient of other two? The coefficient of other two is dr into r sine theta d phi. Then what will be the final value? That is r sine theta dr d phi into a theta. Okay, and now if you want to write the differential surface in the direction of phi, because the surface that we have chosen is in the direction of phi, so I will take the coefficient of other two. So the coefficient of r is dr and the coefficient of theta is r d theta. So the final value is r dr d theta a phi. Okay. So in this way, we have got the differential surface. Now, what about the differential volume? So differential volume is the multiplication of all the coefficient. So R is having the coefficient dr, theta is having the coefficient r d theta, phi is having the coefficient r sine theta d phi. So what will be my differential volume? That is r square sine theta dr d theta d phi. So in this way, you will write the differential volume. So now we have understood that how to write and what are the differential length, volume and the surface. So this is our success saga for GATE 2023. All India rank 50. Under 50 we have got 62 students. All India rank 10. Under 10 rank we have got 13 students and all India rank 100. Under 100 we have got 107 students. That is our achievement in the, and this success is continuing, and we are hoping that you will also become the part of the result of the success of the BYJU'S exam prep in the GATE 24. Okay, and don't forget to subscribe the channel. All the related documents and PDF and everything is given in the description, and you should also download the app because I am and all the other team members of the BYJU'S exam prep in the ECEECS branch are taking the free of cost sessions in this particular app, which will build your concept. So download the app and register yourself. You will see multiple things which is running free of cost for all of you guys, that so that we can also contribute in the building your career. Thank you for watching this. Don't forget to subscribe the channel and join our Telegram group for the latest update. Thank you.